Okay, let's go to Engine Performance 1 Test 4 from chapters 8 and 9, cooling and lubricating. This is good stuff here, which is a mixture of antifreeze water solution, is generally recommended for general automotive use.
B.
50-50, but believe it or not, there are some vehicles that take 70-30 mix. You got to look in there and make sure. Although I don't think you're going to ruin one if you put a 50-50 in it. Always make sure it is 50-50 if as much as you can. Sometimes people keep pouring coolant in one that's leaking. I keep pouring clear water in it, and over a period of time, all the coolant that's protecting the metal and everything's gone, and they just got clear water in there. It starts to turn into rust, and then you got a mess. All of these are functions of antifreeze, except what? Number D, all of them are functions like corrosion inhibitor, coolant system lubricant, rust inhibitor. The following statements are all correct except A, increasing the surface area of a radiator will increase its efficiency. Is that true or false? Every engine horsepower equals about 42 British thermal units per minute. Heat transfer from the coolant to the radiator is more efficient than transfer from the radiator to the air. Heat transfer is most efficient from the radiator to the air. D. For every 1 psi increase in cooling system pressure, the coolant's boiling point is raised how many degrees Fahrenheit?
1. Or is it 3?
3. Technician A says the coolant from upper radiator hose should be cooler than the coolant from the lower radiator hose. Technician B says many front-wheel drive vehicles use a coolant fan mounted in the engine's water pump shaft. Which technician is correct about that? Neither one of them. Have you ever seen a front-wheel drive vehicle? Actually, they could have it could be front-wheel drive and the engine is mounted this way, but just about every car out there now, with very few exceptions, has got an electric cooling fan. Now, he was asking about my wife's Explorer out there because it's got wires going to the fan clutch. And the wires going to the fan clutch are there because the PCM can control the speed of that fan, you know, by changing the valving on the inside of that fan clutch. I got one of those fan clutches up there that came off of a Trailblazer, by the way, that we changed out. You can actually go in there with your scan tool of the PCM and you can change the speed of the fan and see if it's responding to that, you know. Pretty cool. Let me see. Which of the following statements is correct? Overheating will not damage hoses since they're made of flexible rubber. Defective cooling fan circuits may cause overheating at low speeds. Defective cooling fan circuits are most likely to cause overheating at highway speed. Or damaged air conditioning condensers will let the cooling system be more efficient. It's actually B. Low speeds is when you have problems with that. Here's something else. If you've got a situation where somebody's complaining about one overheating, one of the first things you need to look at, particularly if there's somebody that's a deer hunter or the farmer, they drive around out in the field a lot, is you need to take the radiator loose and you need to separate it from the condenser, because you'll be surprised how much trash will go right through that condenser and stop on the radiator. I don't know if you saw that yellow pickups radiator when he had it out over there and it was leaning up, it was all clogged up with dust and crud. That'll make one run hot. And I've actually seen them here where they come in with them grousing because the AC wasn't working right and they were trying to run hot, and you could open it up and you can see all kinds of dog fennels fuzz down in there and all that. Technician A says a defective thermostat can cause overheating. Technician B says debris trapped in the radiator fins may cause the overheating. I just talked about that. That's C. And a defective thermostat doesn't usually cause overheating. Years ago, in my filling station days, we saw a lot of that, and in the 70s. But it seemed like the farther I got into the 80s and the 90s, the more likely it was for the thermostat to fail and cause them to run cold. Now, I'm not saying you'll never see a thermostat make one run hot. We've seen them here, but that's not the norm. Usually the thermostat will fail. Won't always come apart. Sometimes the spring gets weak or something, it'll just start opening too soon. And I just keep that in mind. I will tell you this, though. If it's running hot and you're not sure what's going on and you've already checked your radiator fins, throw a thermostat at it, especially if it's easy to do. You might be surprised how many of them you'll fix like that. That thermostat don't cost much, you know, may as well put it in there. And look, make sure your cooling system's not all clogged up with rust and everything too. High cylinder wall wear rates occur when coolant temperature remains below what? 150 degrees. I have had people that have told me that they would take the thermostat out and drive it that way because they like for it to run really cool. That is not good for the engine. It causes it to wear out a heck of a lot quicker. And on these fuel injected engines, it'll throw you PO125 and PO128 codes, and it causes it to get lousy gas mileage. I want mine to run about 212. Right up in the middle. Technician A says hotter than recommended operating temperatures break down engine oil additives. Technician B says hotter than recommended operating temperatures create varnish and hard deposits. And both those guys are right. You'd be surprised though what the coolant fan threshold is on some of these. You know, first time I was looking at this little Chevrolet Cavalier we had put the motor in over here. I looked up in that thing and the GM book said it came on at 228, which seems pretty hot to me, but the coolant bypass circuit
B.
does what? It eliminates hot spots during engine warm-up, prevents excessive coolant pressure when the thermostat is closed. Everybody like that answer? Doesn't nobody like that answer? Both A and B. Technician, an engine that does not reach operating temperature always indicates a faulty or missing thermostat. How come everybody's so quiet? Give me an answer, somebody. Huh? That's true. But usually, when you see an always or a never in a question, it flags it as false, but in this case, it's true. Now, I will tell you this. One time, this guy contacted me via email, and he said his van was running too cold. And I said, it needs a thermostat. Now, when I was working at the dealership, sometimes even from the parts department, I'd have to get 3 or 4 thermostats before I'd get a good one. You know, you'd get them and they wouldn't be any good and they'd run too cold, and we don't want it running too cold because those codes and everything. Anyway, that guy called me back after we went back and forth several emails, and he said the reason his was running too cold was that the belts were routed wrong. And I don't know if, I'm trying to parse that in my mind. I don't know how that would be. Somebody may have seen that before. I heard of it, but I didn't see it. A cooling system bleeder valve is used to do what? How many of you have seen one? Cooling system bleeder valves. Yeah, they're letting the air out, but which vehicle have you seen one on around here? These GM V6s, you just about always got them. Now, we put an engine in a Kia Sportage that was a lot like the one that you put in that Hyundai Elantra, Adam, and I think so. Maybe thinking about a Chevrolet or some kind. It was a 4-cylinder, and we went and looked in there, and it said, open the bleeder screws when you're filling it up with coolant. Now, you don't have the bleeder screws open when the engine's running, you know, but you're supposed to open the bleeder screws and pour the coolant in there until coolant comes out the bleeders, and that way the air is being pushed out. That one had no bleeders. It said it had bleeders, but there weren't any. And I don't know what they were thinking about, unless they were deleted after a certain serial number or something. So you release the air from the system when refilling. How many of you have seen a thermostat that's got a little hole bored in the plate there that's got a little thing bouncing around in it? You seen that? You know what that's for? Lets the air out when you're filling it up with coolant. That's what it's for. You fill it up with coolant, the air can go pushing out past that little thing, and it keeps it from having air trapped in it. What test is being performed in this illustration here? What are they doing in that illustration there? Look at it very closely and very carefully. They're testing a radiator cap. You notice they got the radiator cap on that little adapter, and they're pumping it up with pressure to see when it pushes open. Radiator cap pressure test. That's the answer to that one. While performing the tests shown below, this is interesting the way this question is worded. While performing the above test shown below, isn't that funny? The pressure increased to 15 psi and then held. It bleeds down to 0 after 5 seconds. What does that indicate? Come on, y'all.
D.
It's supposed to trap that pressure and hold it at 15. If it doesn't, what does it mean?
D.
Leaking. Component being tested is leaking. That's radiator cap. See, they didn't want to give you the answer to the other one. The oil pressure light normally comes on to warn the driver of oil pressure drops below what? 3 to 7 psi. That sounds awfully low, doesn't it? What's the rule of thumb for acceptable oil pressure? Do you know? 10 psi per 1,000 RPM. Got that? If it's idling at 750 RPM, 7 psi is about as low as it ought to ever get. I like to see it run 30 to 50 when it's idling myself. If it gets lower than that, I start to get a little antsy. It will change based on what oil you got in it. Typical oil pump can pump how many gallons per minute?
Was it 50 to 100?
Well, actually I think 3 to 6, but what gets me is I can take
Oh,
that, see
man.
that oil pump with that stem sticking up off of it over there? It came out of that V8. I don't remember if it came out of a Ford or a Chevrolet, but they all look alike. You can stick that pickup tube on that thing in some oil, and you can spin that thing if you spin it in the right direction. And it will squirt oil out of that thing, and it'll go way over yonder. I was just going to demonstrate it one day. I had never done that before, but I says, here's how the oil pump works. And I was spinning it, and I felt like it was going to squirt a little oil out there, and it shot oil out of that thing, and it went halfway across the shop. I mean, that oil pump is a positive displacement thing, and it will really squirt some oil. Of course, you need something like that, you know. And typical, incidentally, here's something I like to do. If I'm building an engine, and you know, some engines when you're building them, you'll actually be able to see the gears on the oil, you know, or the zero rotor if it's around the crankshaft and all that. When I'm putting a motor together that's like that, I like to take some grease and pack it in there around that, because it creates a real strong suction and it pulls oil really fast that way. You know, it needs something in there to give it a nice good suction, because it's not going to clog anything up at all. It's going to push it out of the way. Let me see here. Typical engine lubrication systems, what components are the last to receive oil? Valve train components. Why do you think it is that whenever you get a little bit low on oil and when the pressure starts to fall off, you hear lifters and clackety clackety clack in the top of under the valve covers? And so the valve train is the last thing that gets oil, you know, because it can, I mean, they're pretty smart about the way they design that. But your lifters will actually not, you know, they won't be keeping the lash out of the valves, and it's going to make them clickety click. All the following statements are correct except A. Hydrodynamic lubrication uses a boundary film of oil for lubrication. Hydrodynamic lubrication often prevents metal-to-metal contact. Do you like those? Hydrodynamic lubrication works best in an engine when the lubricated components are stationary? No, they need to be moving. And finally, viscosity of a lubricant affects its lubricating efficiency. All those are true except C. Technician A says most engine wear occurs during engine startup. Technician B says engine oil pressure should build at a rate of 100 psi or per 1,000 engine RPM. Well, I gave you the answer to that a while ago. A is the only one of those guys that's right. Technician A says oil pumps are always driven by the camshaft. Are they? Is the oil pump always driven by the camshaft?
Not always.
What else drives it? I'm not saying you're wrong. Well, the timing chain drives water pumps, but it'll be on the nose of the crankshaft on some of them. On the Toyota Camry that we got out there on the stand, it's driven by the timing belt.
I know on a Ford Ranger, a little four-cylinder, you gotta line up the cam, the head, and the pump.
Well, yeah, there's a mark on there, but you don't. The only reason you need to line that one up, does yours have a distributor? If it's got a distributor, you got to line that up. And they use the same gear on the one that had a distributor and the one that didn't. But on the one that didn't, it don't matter where you line that gear up that turns the oil pump, because the oil pump can't be out of time. You know what I'm saying? But on the ones that had a distributor, if you pull the timing belt off and you didn't line that back up, your distributor would be pointing somewhere else and the darn thing wouldn't start. And the distributor actually is where was going down there to drive the oil pump. On yours, it's just got a little thing that looks like the bottom of a distributor going down there driving the oil pump, but it ain't driving the distributor.
On mine's got a V6.
Yeah. Well, you're talking about a 4-cylinder Ranger, though.
Yeah.
So, yeah, your V6, okay. Yeah, yours is a 3-liter, isn't it? Yeah, all right. And what year did you say it was?
You know what?
Your Ranger?
The year.
What year?
92.
Yeah, that sounds about right. 89 to 92 looked like that one, and then they changed after that, and they were different before that, you know. Let's see, I gotta look to see if I found it where I am.
40.
21.
Which of the following is not a type of oil pump? Oh, I'm sorry, I didn't finish this other one. Technician B says that oil pumps are always driven by the crankshaft. Well, neither one of those guys are right, because, you know, that's an always thing. Which of the following is not a type of oil pump? Rotor, positive displacement, negative displacement, and gear. There ain't no such thing as negative displacement. They make it up as they go. All right, number 22. All of the following statements are correct except what? The anti-drain back valve determines maximum oil pressure. Pressure regulating valves are located at the oil pump outlet. High viscosity oil will have a higher oil pressure than low viscosity oil. Cavitation means the pump draws in air. That's actually A. The anti-drain back valve does not determine maximum oil pressure, but it does keep the oil galleries full of oil when you shut the engine off. And it's usually in the oil filter housing or area or whatever, usually. But the other end of it is pressure regulating valve is the one that determines maximum oil pressure. Got that? Now you know how the pressure regulating valve works. Have you heard me tell you this before? How does the pressure regulating valve work? I know you guys are really all over this. I can tell you're really excited about it. If you've got a positive displacement oil pump, is that positive displacement oil pump what creates the pressure?
Yeah.
It moves the oil, but it doesn't create the pressure. The pressure is created because it's got a spring and it's got a plunger, and that spring has got to be compressed so that that plunger can move to open a port and let the oil pressure go out and exhaust, and the strength of that spring determines the oil pressure. I built an engine one time when I was working at the International dealership over there. It was a gas burner, one of them, you know, tilt front load stars. And everything was right. Everything was plastic gauged, all that stuff was right. The one thing we didn't change out was the oil pump, and it had low oil pressure on it. And I said, I know there ain't nothing wrong with the fit of the bearings and all that kind of stuff. God, really careful about that. So I took the oil pump apart and I pulled the little pin out. And I got the spring and the plunger out of there and cleaned all that up. And when I put the spring back in there, I put 3 or 4 little washers, little thin washers to give that spring more tension. And I put that Scotter key back in it, and the oil pressure was like 60 psi. Because see, the spring behind the relief valve plunger was weak. And when technically we needed to put a oil pump in it, but the boss man hadn't priced that out, and he didn't want to hear them squawking about it. So anyway, we just fixed that one. That's all that was wrong with it. The spring just needed to be strengthened a little bit. That's sort of an irregular way of fixing something, but in the olden days we did stuff a different way usually. Technician A ensures the holes in the engine bearings align with the holes in the block saddle bores. Technician B says bearing failure is almost never due to poor lubrication. That's A only. These curved metal bearings, you'll see, if they've got holes in there and there's a hole in the saddle bore, they need to be lined up so that they're not blocking that. You know, just be careful when you're looking at that. And some of them will basically, well, I'm not even going to dig into that all that deep because that's more of an engine repair thing. All of the following statements are correct except A, oil pressure warning systems work by completing the ground circuit. B, minimum acceptable oil pressure is 10 psi. C, warning lights are designed to illuminate at 10 psi. D, all of the above are correct. Which one is that? 24? That's actually C, but that contradicts a previous question on the same test. You remember that one that said 3 to 7 and this says 10? You know, I mean, the same test gives you 2 different answers. If you're looking at one, you're thinking, how can this one be true when that other one? When measuring oil pump rotor tip clearance, what should the clearance be? And that's something I'm sure that everybody knows, but it's 10/1000ths of an inch. Lubrication between 2 moving surfaces occurs when an oil film separates the surfaces and supports the load, which is true. Engine oil temperature must be above 212 in order to boil off any accumulated moisture That's true. Oil pump and clearance should be less than 0. What do you think?
False.
Actually, shouldn't be less than 0. That's false. Now, on that moisture thing, you know, one of the things I preach about a lot, and I've told my wife this repeatedly, don't crank your vehicle up and drive it somewhere and park it and shut it off when it hadn't had time to warm up. Because if you do that enough, you're going to have so much sludge in your crankcase, you ain't even going to be able to see the parts if you take the valve cover off. And that's bad news. The reason you got the sludge in there is you're making a gallon of water for every gallon of fuel you burn. Some of it goes into the crankcase's blow-by, starts to mix with the oil, starts to condense in there. You haven't got it up, the oil up to 212 to boil the moisture out of it so the PCV system can take it away. And then you wind up with a mix of oil and water in there that's just nasty. You seen that stuff? You pull them off, you see that sludge in there? Now, oddly enough, Toyota back in about the 2000, 1999, 2000, 2001, they made a bunch of vehicles, Corollas or something, I don't remember what they were. They had a PCV system that was poorly designed, and they had to change out engines because of sludge. It's less expensive to change out an engine than it is to de-sludge it. Of course, you know, in your mind, you're thinking, well, that's an engine that's just dirty, it needs to be cleaned out. But there's too much going on there. And even Dodge, you know, like I've seen them at the Dodge place over there, if an engine's got a lot of sludge in it, for whatever reason, they put a motor in it. They don't take it apart and clean all the sludge out, put it back in there. Now, if I was working on it myself, yeah, but the labor gets it above the point of where it's cost effective. Technician A says oil pressure is affected by the amount of main and rod bearing clearance. Also, that incidentally, that other thing is the real cold thermostat or taking a thermostat out sludges them up too. Technician A says oil pressure is affected by the amount of main and rod bearing clearance. Technician B says the oil pressure is lower when the oil gets hot than when it's cold. Which technician is correct? That's C. Technician A says many engines use a windage tray in the oil pan. Technician B says some engines are equipped with an oil cooler. Both those guys are right. I had, as we close this class session, there was a Chevy Cavalier. No, it wasn't a Cavalier. It was one of those funny looking 80s model, early 80s model cars. It was a sort of a hatchback looking thing. It's a Citation, I think. And Pontiac had a Phoenix that they made. And I had one of those cars in there. And that car had, I can't remember why I originally worked on it, but we were going to put a crankshaft in it. And so what we did was we pulled the motor out of it and flipped it over and got a crankshaft kit. Now, does everybody know what a crankshaft kit is? Crankshaft kit comes with bearings and crankshaft. They're supposed to be machined where they match each other and all that sort of thing. Drop that thing in there, greased it all up, torqued everything down, popped it back in there, fired it up, and the oil pressure was not as high as it should have been. So we took the pan back off, and we took the one of the main bearing caps off, and we put a business card in between it and buckled it back up, and we checked with plastic gauge to see how much clearance there was on the other bearings, right? And whatever happened, the point is the bearings didn't have, had too much clearance. They had like 2/1000ths of clearance between the bearing and the journal. And that was causing oil to squirt out there. But you can find out where the oil pressure is going by taking the oil pump off and putting the oil gallery full of air. All right, so he says, the shop foreman says, let's pull the crankshaft back out of there and let's send it down to the machine shop, and they can machine 9/1000ths of an inch off of it, and then we'll get some 20/1000ths undersized bearings. You see where I'm going with that? It started out 10. If we machine 9 off, then the crankshaft will be a little bigger than that. And of course I had to pull the transmission out, and with the motor still in the car, I pulled the crankshaft out. Now that's a trick, but it's doable if you know what you're doing. Pull it out, send it over there, put it back together, and I'll be doggone if we still didn't have too much clearance. I mean, this was getting old. And so finally he says, you know what? He said, it's not going to hurt anything. Let's just go ahead and take all the main caps and we'll file them a little bit, which is what we did, and we reduced the clearance that way and fixed that dadgum thing. Wow, I think that wore me out. And you're doing everything right, but things keep going wrong. And of course, I got paid labor every time on that one because it wasn't my fault.
So, on a lawnmower, I say getting a clearance on your rod.
Yep, file them, yeah, that's right. And they don't have bearings,
It's built into the rod.
yeah. I mean, I think I'd rather have a bearing than not, but them lawnmowers run a long time. Anybody got any questions or comments about that? You got any war stories? All right then. What do you think? I bet you've got a war story, don't you? What'd you do this morning? Tell us what you did this morning. She did. She fixed one. I mean, what did you do? What'd you find? Talk loud. Yeah. I'll turn off the camera. All right.